Good evening and welcome to our launch coverage for IXPE, or the Imaging X-ray Polarimetry Explorer for our customer NASA. My name is Shiva Bharadwaj and I'm a space operations engineer, and I'm joining you from SpaceX headquarters in Hawthorne, California. The Imaging X-ray Polarimetry Explorer is NASA's first mission dedicated to measuring the polarization of X-rays from a variety of cosmic sources, objects like black holes and neutron stars. We'll have a little more on the science IXPE will conduct a bit later on in the webcast, but for now, let's take a closer look at the rocket on your screen. This is Falcon 9, our two-stage liquid-fueled launch vehicle. It's standing vertical at Launch Complex 39A. Now, the booster supporting today's mission is flying for the 5th time, and this also marks SpaceX's second flight-proven launch vehicle for NASA's Launch Services Program, or LSP. Now, this booster first flew in November of last year. It since has carried 3 Dragons and 8 astronauts to the International Space Station on the Crew 1, Crew 2, and CRS-23 missions. It also flew the Sirius XM-8 satellite to orbit earlier on this year. Now, as I mentioned earlier, today's IXPE mission is for our customer NASA, and it's the first NASA Launch Services Program mission being launched from Launch Pad 39A. But it also marks SpaceX's 5th as part of the NASA Launch Services Program missions. Those science missions include the Double Asteroid Redirect Test mission that we launched a few weeks ago, the Sentinel-6 Michael Freilich mission in 2020, the Transiting Exoplanet Survey satellite launched in 2018, and JASON-3, which launched in 2016. But our payload tonight is a collaboration between NASA's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace. The Imaging X-ray Polarimetry Explorer will help us understand fundamental physics of some of the most energetic cosmic objects in the universe by studying the special properties of the X-rays that they emit. NASA's Tiffany Russell Lockett will give us a closer look at the main components of IXPE, where those X-rays come from, and how studying their polarization will help us better understand the universe in the years to come.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the 2 types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
T-minus 30 seconds.
Let's listen in as Falcon 9 takes IXPE into orbit.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Go Falcon. Good hunting, IXPE.
Vehicle is pitching downrange.
Nominal first stage chamber pressures.
T plus 40 seconds into flight, successful liftoff of the Falcon 9 from Launch Complex 39A
Power and
at the
telemetry
Kennedy
nominal.
Space Center. We're carrying the IXPE satellite into an equatorial orbit, and we just throttled down the 9 Merlin 1D engines in preparation for the next event. That's the point of max Q, or maximum aerodynamic pressure. That coming up in about 10 seconds.
Vehicle is supersonic. Max Q.
So with that, we are through the highest stresses on the vehicle from the combination of our increasing velocity and the decreasing atmospheric density. Coming up next, the next event in about a minute will be MECO, that's main engine cutoff. We'll shut down those 9 Merlin 1D engines in preparation for the next event, stage separation. The first and second stages will separate, and then at about T+2 minutes, 44 seconds, we'll have SES1, or second engine start number 1. That's where the Merlin vacuum engine on the second stage will ignite to carry the second stage and the IXPE payload into orbit. So again, those 3 events coming up in succession: MECO, main engine cutoff, followed by stage separation, and then SES1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the atmospheric density drops off, so we get higher and higher in our atmosphere.
First stage engine cutoff.
Stage separation confirmed.
And back ignition.
So those 3 events successful: main engine cutoff, stage separation. Left-hand side of your screen, you can see a view of the first stage deploying its grid fins, starting its recovery sequence. The second stage on the right-hand side of your screen, we've got a shot of the Merlin vacuum engine glowing as it continues its ignition to carry IXPE into orbit. Next major event coming up will be fairing deployment. At this point, the second stage...
Stage 2 on nominal trajectory.
The second stage is getting to a part of the atmosphere with very low density, so we don't need to carry those fairing halves anymore. We can jettison them back to planet Earth and then attempt to recover them. Again, both of them being new fairing halves flying for this mission.
Fairing separation confirmed.
There's confirmation of the fairing deploy, the IXPE satellite now getting directly exposed to the vacuum of space.
Stage 1, entry burn startup.
So left-hand side of your screen, you can see the grid fins and you can see the plume from the entry burn. At this point, we are firing 3 of the Merlin 1D engines. And we're decelerating the first stage, but we're still going pretty fast. So as we're flying into the Earth's atmosphere, that soot is actually getting kicked back, the plume is getting kicked back.
Stage 1, entry burn, shutdown.
Onto the first stage. And next events coming up will be second engine cutoff number 1, that's shutdown of this Merlin vacuum engine. And pretty close after, we'll hear a call out for landing burn startup on the first stage.
Stage 1, landing burn.
And back engine cutoff.
So shutdown of the Merlin vacuum engine. We've got landing burn startup on the first stage. Left-hand side of your screen is a shot from the drone ship.
Nominal orbit
Stage 1,
insertion.
landing leg deploy.
And correction, that's a shot from the first stage. And on the right-hand side is a shot from the drone ship. We've deployed the landing legs, hopefully for a soft touchdown on just read the instructions.
Stage 1, landing confirmed.
And
Expected signal, Kate.
that is a 97th successful recovery of a first stage on our drone ship named Just Read the Instructions. This particular first stage having scored 5 flights under its belt. So there's ignition of the second stage engine. This burn was expected to last about 40 seconds. Now the initial orbit that the the second stage went into put it at about a 28-degree inclination with a high apogee and a fairly low perigee. This burn is taking us down to 0 inclination. That means we'll be flying over the equator, and it'll put us into a circular 600 by 600 kilometer orbit. And you're looking at live views of the Merlin vacuum engine and some photobombs from planet Earth behind it.
Terminal guidance.
Nominal MVAC cutoff.
So with that, the second stage engine, the Merlin vacuum engine, has shut down. The launch team will be reviewing the orbital parameters.
Nominal orbit insertion.
And with that call out, we are in the expected circular orbit right above the equator, about 600 kilometers above the Earth's surface. Now, as a reminder, the IXPE satellite is still attached to Falcon 9's second stage. We've got payload deployment coming up at about T plus 33 minutes. We're about a minute away from payload deployment. And once we get into payload deployment, the IXPE satellite will then get to proceed with its 2-year mission. Now, IXPE is an orbital observatory. Its job will be to study the laws of nature on astrophysical objects that we can't recreate in labs here on planet Earth. So we'll use the telescopes on IXPE to observe them in parts of our universe. Over the next month, the satellite team will conduct checkouts of the vehicle. They'll extend a boom that holds 3 telescopes on the satellite, and then they'll start observing some of those astrophysical objects. The first one will be a supernova remnant, so the remains of a stellar explosion in the Cassiopeia constellation. It's an object that's about 11,000 light years from planet Earth.
And payload separation confirmed.
So there's confirmation of payload separation. The IXPE satellite floating away from Falcon 9's second stage to begin its 2-year mission to study some of the most energetic objects in the cosmos. And with that, it's going to end our webcast coverage for today. So we want to give a big thanks to NASA for entrusting us with today's mission, SpaceX's 5th NASA science mission to date and the second in the last couple of weeks. We also want to give a big thanks to the Range and the Federal Aviation Administration for supporting today's mission. And of course, thank you for tuning in, and we'll see you again for the next launch.